All right, relatively straightforward for us here. To start with, what are the forces acting on that block? Owen, what do we got?
Get the weight going down and the normal force going up.
Weight going down, normal force going up. All right, awesome. All right, so the next picture I want you to draw are the forces acting on that block as I push him towards the end of the table. Right now. I'm pushing this thing towards the end of the table. What are the forces acting on that block now as I push it towards the end of the table? I'm pushing, I'm pushing directly horizontal. Let's make it easy. I'm pushing directly horizontal.
I realized, I just realized that. I said kind of talking to I know, I just realized that. They're a specific kind of drug. You could tell the same person. They were all these people that really large.
Okay, Richard, what are we adding to this picture right here? We still got weight going down. Still got the normal force going up. What are we adding, Richard? Yeah, whatever direction I'm attempting to push this in, there is now a force of static friction that goes in the opposite direction. Okay, now, next one. Now, I push this thing towards the end of the table, and it's now moving across the table. What are the forces acting on that object as it moves across the table?
Okay. Oh, yeah, she's right.
I took it twice. I should not.
Okay.
All right, Zoe, what change did you make?
We still had normal and then the force of your hand, and then we changed the force of friction to kinetic.
So as I push, if the thing is not moving, there's a force of static friction that is balancing out my force. God bless you. I push harder, 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 harder. What happens to the force of static friction? It increases, gets bigger, 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 but ultimately it reaches that limit. Then the thing begins to move, and now there's kinetic friction that's opposing that motion. What do we know about the value of kinetic friction compared to the value of the maximum static friction? It's got to be less. Okay, all right, let's take the gloves off now. All right. Now, what are the forces acting on each of those blocks? What are the forces acting on each of those blocks? Let's label them bottom and top. B and T.
No, we cannot.
Let's label bottom and top.
Okay, top, the weight down. What's on top? The weight of the bottom down. Right? Where's the force?
Well, it's also force normal. Wait, no, force normal is force normal.
Oh, wait, no, we can do it. It's still force normal. Force perpendicular. Isn't this the force? No.
Not
The
sure.
top by the bottom, and this is the force on the bottom by the top.
Yeah, but I think that's just.
No, it's backwards. Yeah, the other way.
But that's just normal.
Yeah.
So a couple things, right? So what's that? Okay. And yeah. Now the sign would often be what the problem is. Because does the top block push upwards on the bottom block?
Yeah.
You basically.
Okay, so is it, this is force on the bottom by the top, force on the top by the bottom. So what's on here? Force normal? No, force. Ever since that video said force normal,
All right, step three. All right, what's your group got? What are the forces acting on this bottom block right here? Okay, so the weight of the bottom block, I like. I do not like the label, the weight of the top block. Okay, now, right now, numerically, that's the case, right? But if I were to throw this thing on there, right, like what's acting on the bottom block? The top block is pushing down on the bottom block. Let's not assign a value to it. It might be equal to the weight, but the force that's acting on this is not the weight of this thing. The weight of this thing acts between this thing and the earth. So what that force should be labeled is something like, I don't know, force of the top block on the bottom block. Let's just say, for instance. Okay? What else, Jeffrey? Anything else acting on that bottom block? The normal force is acting upwards. Okay? Richard, what about the forces acting on the top block?
There's the weight of the top block acting downwards and the normal force of the bottom block acting up on it.
Ooh, I love that. So the weight of the top block here. Now, all right, Richard labeled it the normal force of the bottom block acting on the top block. Right? So I love that. Right? Keep in mind, it's a normal force by nature. It's got to act perpendicularly up from the surface. We've got that labeled as FTB, right? So I'm going to keep that consistent so we know that this is an action-reaction pair right here. All right? What do you think of that, Maddie? How's this look?
can you keep it, or can you make it force of the BT, because technically those are the same?
Yeah, like look, you can label these two things anything you want, okay? And sometimes I'll say, okay, this is the force of the bottom block on the top block. Other times, I like to have the exact same label to get everybody to understand that they have the exact same magnitude. So yeah, whatever system you kind of want. But hey, express what your knowledge is to everybody that's looking at this piece of paper. Right? So if you have this labeled different than this, someplace down here, probably put an equal sign. Okay? Now Cheryl's group, I like, they also had a system diagram. But we need that, but I'm not going to put it here because I want to get cruising here. All right? So let's go to the next one. Here's the next one. I am pushing the bottom block towards the front of the table, and nothing is moving. I'm pushing the bottom block towards the front of the table. Nothing is moving. I want just the bottom and the top. I'm only going to do the bottom and the top. What are the forces acting on that thing?
Cheryl, that was the weakest small compact I've ever heard.
Force of yeah. Is there any? I don't know.
Yeah, there should be. This wants to stay. If it was a frictional surface, when you push the bottom block would shoot out under it, and the top block would stay where it is. So I think there's some force of friction acting in the other direction.
But you're not wrong.
No. No, I'm sorry. I think force of friction is what's pulling it along. Force of friction would be acting in that direction, so it's holding the block. Yeah. And then there's
Wouldn't the force of friction that goes down and you're holding it up top of the other one?
I don't know. You got a little Irish.
Did I actually? I didn't put two. Yeah, yeah, that's just this one. I don't think there's any. Okay.
Emma, that is music to my ears.
Let's go.
So the debate, as I walk around the room, the debate, there's no debate here, right? Like the bottom picture looks just like a combination of this and this, right? The debate centers on, hey, what's happening to the top block horizontally, right? There's no debate vertically, right? I've got F, T, B, and I've got weight of the top, right? The question is there stuff / friction acting on that top block? What do you think, Emma?
No, because the top block it still wants its desires to stay still at rest because there's nothing acting on it. There's no friction between the two surfaces.
Let's go back to here. Is there any friction between these two surfaces? No, because the block has no desire to move. I push it like this. Is there now a desire for that block to move? Yeah. So static friction is opposing that desire. Make sense to everybody? All right. Now, I put this thing on top of it. If I push on the bottom block, is anything pushing on the top block? No. So what does it have the desire to do? It's funny that one time I walked by and Jack said, yeah, because if you yank this thing out from there, what would happen? It has the desire to fall straight down. Okay? All right. Next one. Now I push across on the bottom block. And they move towards the front.
Oh no, we missed that. Oh.
Oh my gosh, it's getting worse.
I'm trying to do
It
a
looks like a new face. No matter what.
No.
Oh, Mark. Mark.
Get it? No, what? What? That's an 8.
No, because no, there's no force here. There's no frictional force. It's not sliding against the surface. It's staying on the surface.
No, but there's no force. No.
It's moving. So this is saying that this is not
There's no force.
Yeah, but this top box physically cannot be like this unless it's
Oh, that's because if you can't solve it, it's just
right.
But then it's over the static.
It can't because it's not moving. It's staying on the surface. Okay, what if I was sitting in a cart and you were pushing the cart? There's static friction. There's kinetic friction on the cart. There's no kinetic friction on me because I'm not sliding.
Oh, I see what you're saying.
But what if
It's accelerating at the same rate.
well, it must be like the same block. It's like,
Well, this would have to be equal to this.
yeah, that's what I'm saying. So it's like,
So it is so force.
There's no friction slowing down, but still moving.
it's like you just cut a block. Like the whole block is still the same force action. I'm not sure. I think it's too check.
No.
I don't know that you can change this to make it an effective coefficient of friction. It does have a factor though. Why is it not go with the bottom block?
Caillou, I was not allowed to watch Caillou because he whined too much. What is it? Is it straight up? Or is it like?
Is it standing up?
I think it's like more like he has 3 lines like that.
No, that's not it.
Is it desire to stay?
I know. I always
Desire
look
to stay exactly where it is. Alright? You guys are still missing something.
We have every
Actually, you're not. You're not missing anything yet. Alright, so, hey, has anything changed with block B? No, nothing has changed. Alright? I still got all these things. I'm not even going to repeat it. Alright? I got the exact same picture. However, the top block, actually, I'm gonna put the horizontal stuff right here. So I got this F, and I've got the force of kinetic friction right here. Okay? Now, for the top block, I still have the weight of the top block going down, and I've got the force of the bottom block on the top block, which we're going to label F sub T sub B. Okay? However, Ryan, what is making this block go forward? Friction is making the top block go forward. How, what? Friction's job is to oppose motion. How can friction actually, now, first off, it's a static friction force. Why is it a static friction force? Owen? The top block and the bottom block are stationary with respect to each other. All right? Now, what the heck? How can that possibly be? Why is friction's job to make this thing move forwards? What? Huh? Well, because what's the top block's desire? No. To stay exactly where it is. So now, if I move the bottom block and the top block stays the same, relative to the bottom block, how is the top block moving? Backwards. Its desire is to move backwards. So friction going forward is actually opposing its desire to go backwards relative to the top block. Or to the bottom block, rather. Whoa. Emma.
Does the force of the side friction have to be equal to the force of your hand? Because they're moving at the same rate.
Great question. When would the force of does the force of static friction have to be equal to the force of my hand? No. In fact, that would be determined by how much friction there actually is between the objects, right? So, that's a good question. Does this force have to be equal to that force of static friction? The answer would be no, right? Because my force is acting to move the bottom block. If I change all this stuff out, right? Like the size would have to vary based on what the size of this thing actually is. All right. Now, wait 1 second. Right. What if I do this, right? What if I do this? And now that thing slides backwards. All right. Now there's a force of what type of friction going forwards? Kinetic friction going forwards. Bad question.
So the force on the top block, the force of friction, that's static friction?
Yes, because it's balanced. Like again, there's two different, look at, there's two different surfaces here. Tire and table, tire and top block of the wood. This is static because relative to each other, they're stationary. This is kinetic because relative to each other, they are moving.
So if you were like push the bottom block really fast, then the force of the friction will be like overcome, and then the top. Oh, I get it. Okay.
All right. What happens here? Right? There's less friction. Ooh, I think I'm off of here. It's easier for me to slide that top block off the bottom block. All right. All right. Head back to your desk. Let's do this example. Let's do it in 2-3 minutes. Let's give you 10 minutes to maybe sort through some stuff if you need to. Hey, I'm not putting this on the quiz. I don't envision this being part of the test because when we get back from Christmas, we're going to pivot just a little bit, right? And there'll be a specific unit when we get back from what you call it. But I felt the need to kind of have this exchange with you. Okay, what's going on here? 2 blocks, blah blah blah. The coefficient of kinetic friction between all surfaces is 0.25. Find the magnitude of the horizontal force necessary to drag block B to the left at a constant speed if A rests on B. Now look, one of the things we didn't do in that little exercise is we didn't do the system diagrams, right? Because that was not my intention. If block B rests on block A, or block A rests on block B, how many objects do we actually have? It's really just one object. If block B rests on block A, just treat it as one object. And you don't even have to get into any of that stuff. If all it's doing is, unless it asks you something specific to block A. This question does not, right? Find the magnitude of the horizontal force necessary to drag this entire system forward at a what? Constant speed. Maddie, what's the significance of that? Sum of the force is equal to 0. Now, what are the forces acting on this system? Well, if I drag it forwards, what's going in that direction? Force of kinetic friction. We've got the weight of the system going down. We've got the normal force going up. We're trying to find F, so we're talking about horizontal stuff. Cheryl, can you give me an expression for the sum of the forces acting horizontally?
Force minus the force of kinetic friction.
Perfect. So then what do we know about the size of F, which is what we are trying to find? It's the same as the force of kinetic friction. Do we know the force of kinetic friction? No? What can we replace the force of kinetic friction with? Mu times the normal force. Do we know the normal force? It's the weight of the system, so let's replace it with the weight of the system. Do we know the weight of the system? Yeah, it's 5.4 plus 2.7. So F equals 0.25 times 5.4 newtons. Don't even care what that is, but I think it was like 2.0 something. Something in that range. Again, I don't really even care what that is. Oh, you know. Now we got ourselves a little bit of difficulty. And we're going one step further than what we did back here. Because now, this string holds block A. So you can imagine block B slides out from underneath block A. Right? Does that make sense? Ooh, okay. So what are our force diagrams? What are the forces acting on block B? Obviously, we've got F going this way, right? If block B is sliding to your left, what's going to the right? Force of kinetic friction. The weight of B goes down. Oh, the weight of B goes down. What What else pushes downwards? Force of A on B. So I'm going to call that FAB, because that's how Maddie said. And then the normal force is pushing up. Okay, well, what about block A? Tension string pulls where, Maddie? To the right. So block A's relative motion desire with respect to block B is this way. Which means what's acting this way on block A to try to get it to go the other way? Force of kinetic friction. Now, is that the same force of kinetic friction as here? No. So I'm going to label this as FFK2. Oh, wow. Because it's different than this. Block B is pushing up on A, just like block A was pushing down on B. We're missing one force, someplace on these diagrams. It's a $100 question. Maddie.
Do you have to account for the force of K2 on block B?
Boom! $100 to her. Payable in 2080. All right? That's an action-reaction force. We neglect that. Because, hey, if there's friction between the ground and B that's pushing B to the right, this friction force is actually pushing this ground to the left. Do we really ever worry about that? No. Except when the two surfaces are both movable. So in reality here, if the friction between A and B wants to pull A forward, what's it want to do to B? Push it backwards. So I've got FFK2. Okay. So as Cheryl said, sum of the forces equals 0. Cheryl, what's your new expression for sum of the forces acting on object B? Yep. So then the force that we're looking for is now, it's not equal to just one friction force, it's equal to the sum total of the two friction forces. Now, what is the force of friction 2 equal to? It's equal to mu times what? FAB, right? As we have it labeled. And the force of friction K1 is mu times what we have labeled as the normal force. Well, what does FAB equal? The weight of A. Because is A accelerating up and down at all? Nope. And what's the normal force equal to? The weight of B plus the force of AB, and the force of AB is equal to the weight of A. And that's what a lot of people want to do, right? Like a lot of people want to label this force as the weight of A. It's really not the weight of A, but is it numerically equal to A oftentimes? Yeah, or the weight of A? Yes, right? So in reality here, mu down here just becomes then the weight of A plus the weight of B. 5.4, 2.7, 0.25, 2.7, 0.25. I'll post this thing online for you. Now, I would have liked that to take 10 less minutes so you had a little bit of time to work today, but like that was too good to resist. You did too good of a job to cut that short, right? And I hope you see, right? Like this is super complicated, but you did a really good job. Now, why did you do a really good job? Because you're used to evaluating what forces are acting on objects. You made adjustments based on what you saw. And because you are getting better at it, you can handle more complicated situations, right? Like we would have thrown this at you on day one. Like, you can't do that. But now you're getting better at it. Yeah? Anybody have any questions on this? All right, now listen, tomorrow, all we're doing